Okay, so we're going to talk about lenses. So before we go into talk about lenses, it's probably important that we first talk about refraction. So let's imagine that you had a shopping trolley here with two wheels at the front and two wheels at the back, like so. And this shopping trolley was being pushed in this direction, like so. Now let's imagine that we were pushing this shopping trolley on a concrete road, and then we came to a beach where there was some sand. Now what's going to end up happening is as the shopping trolley approaches the sand, when these wheels here and here enter the sand, they're going to slow down, as it's going to be harder for the shopping trolley to pass through the sand at the same speed as it passed along the concrete road. Now that's not going to mean anything in terms of its direction of travel if the shopping trolley hits the sand at straight on. It will just continue to carry on going straight. However, if we had an angle and the sand actually started in this direction here, then what is going to end up happening is the shopping trolley, which I can just move over, is going to hit the sand like so. And if we imagine that this wheel here is going to enter the sand first, and this wheel here will continue to carry on at the same speed, well, the sand that's entered the sand first will end up slowing down, and this wheel here will continue to carry on at the same speed. So therefore the shopping trolley will slightly alter its angle as it enters into the sand, like so. And this metaphor is what happens to light. And the shopping trolley is the ray of light. So if we imagine we have a ray of light, like so, and in the case of the sand is representing, say for example, glass, which is a slower medium that light will travel through in comparison to the road, which was representing air. What's going to end up happening is this part of light will slow down, this part of light will continue to go the same speed, and we'll end up with a refraction. The angle of this refraction is dependent on a couple of things. It's going to be dependent on the speed of which light travels through the object that we've put in front of, and also it will depend on the angle of the light approaching the object or medium. So let's have a little bit of a think then. If we had, say for example, a ray of light shining straight at a glass box, so this is our glass here, this is our air. If you could pause the video and try and work out which way the light would refract. Okay, so hopefully you've done that, and you are aware that this metaphorical wheel, if you like, or this part of light will slow down, this part of the light will continue to travel at the same speed, and so the refraction will occur downwards in this direction. Okay, so what we also need to have a think about is what happens at the other end of this. So let's say, for example, my ray of light is traveling in the glass, and then it moves back into the air again. Well, in this scenario, what we've got to picture is that, let's go back to our shopping trolley again. We have our shopping trolley here, like so, and this part here is going to enter into the faster air or faster concrete road, and so this wheel is going to start being able to move faster again, whereas this wheel here on this side is going to still be traveling at the same slower speed, and so the shopping trolley will rotate round as it passes through, and the refraction will occur in this direction. So if we picture that with a ray of light, And let's now mix that up in that direction. If we have a ray of light in the glass and then now leaving the glass, could you pause the video and try and work out which way the refraction would occur? Okay, so hopefully we've done that and we've realized that this wheel here, or this part of light, will travel faster as it enters the air first in comparison to this part, which will then result in the refraction in this direction, like so. Okay, so what we come across then is we can come across different types of lenses. Now, we can have a lens which looks like this. And how I'd describe this lens is I'd say that it is fatter in the middle than it is on the edges, and we call it a convex lens. Now, if I have light passing through the middle of this convex lens, it will just pass through straight. And I'm going to call that here my parallel axis. Then if I have a think about what might end up happening if light was to pass through at this location on the lens, well, I have to have a bit of a think about my metaphorical shopping trolley, this being glass and this being air. Well, when this side of light passes through the glass first, it's going to slow down. This part of light is going to continue to travel at the same speed, and so we're going to have a refraction down like so. And then the same is going to happen if we have a picture this on this side. We're going to end up with this part of our shopping trolley, or wheel of our shopping trolley, or this part of light leaving and going into the air first, so therefore speeding up. This part staying the same speed, and therefore the refraction is going to continue down in this direction.